This is a talk basically where I'll be talking about how you can use machine learning inside HeatWave and how you can basically incorporate both machine learning and generative AI in your applications, in your MySQL applications actually, without basically learning anything, like without making any significant changes. So again, skipping this. So just to give you guys a quick overview, we all know that MySQL is like the single platform to do it all, right? So you have basically the MySQL at the front end. So basically you have your SQL applications. It can be OLTP applications, it can be your analytics or OLAP applications, or it can be basically your machine learning applications. So all of this is done via the same MySQL, like your standard SQL interfaces. There are very few new APIs you have added. So all of this basically works with your existing MySQL connectors, all the existing application, all the tools and everything that MySQL has built. So you can, all of that works with machine learning. So in the background, using HeatWave, we can actually accelerate all of this. And so yeah, making this very easy to use. So it is fully automated, it is very scalable. You add more nodes to the HeatWave cluster to make your training faster, to increase the prediction throughput, and so on. All the machine learning happens within the database, so no data leaves the database. So you don't have to create this complex ETL pipelines to, okay, I have this separate, like I'm using SageMaker, I'm using MySQL, let me move my data from MySQL to SageMaker, do machine learning there, create a model, move it back, and so you don't need to do any of that. Like everything happens within the database, and that's where the future lies, right? And of course, our APIs are easy to use, making them friendly for everybody. And of course, the biggest thing, at least to me, is like this is at no additional cost to HeatWave customers. So if you have a HeatWave cluster where you are doing OLAP, which you are using for Lakehouse, you can just use it for machine learning as well. So you don't pay anything extra for machine learning. So what I'm going to do is I'm going to walk through some I'm going to like make this talk very high level. So actually I want to just ask you guys, like, how many people here have actually used machine learning or have built a machine learning application? Not people from my team. Okay, so yeah, that makes sense. I'm going to give a very high level overview of what machine learning use cases look like, right? And how do you guys think about machine learning, or how, like, what these applications look like? So one of the first things, one of the most basic classes of applications for machine learning are classification and regression applications. So what classification means is you're essentially predicting a category. For example, I want to predict whether something is, let's say, fraudulent or not fraudulent, right? So that is the classification use case. And of course, like some of the examples here for you guys are like, you can classify a loan application into approval or denial, right? And then of course, with HeatWave AutoML, you can explain why that loan was approved or denied. So that's one of the capabilities we have. And then of course, you also want to determine, this is using prediction explanations, what can I do to actually change my loan from a denial to an approval. The second class of use cases is regression. So for regression, basically you are predicting a real value. So real value means I want to predict basically, let's say, the stock price, or predict the interest rate, or predict basically one of the, like our actual use cases was predict how many days will it take for a client to actually default on their loan. So that's regression. Next comes forecasting. So forecasting, as we know, is again something we all have done in Excel quite a bit, where you essentially are predicting, you have some sales data for the last, let's say, 1 year, and you want to predict what my sales would be in the next month, or next 2 months, or next 3 months. So that is the classic forecasting use case, right? So of course, you can predict electricity demand. Like this has a lot of different applications in enterprise scenarios. Next up is recommender systems. So recommendation systems are basically when you are trying to recommend, I mean, the easiest way to think about recommendation systems is Netflix. I'm pretty sure most people here are familiar with Netflix, where you are essentially recommending items to users. So users have a profile, items have some metadata about them. You're trying to match based on a user's history of what they have watched or what items they liked, what new items to recommend. So any e-commerce website or any, like a lot of solutions are built on recommender systems, and of course, and it's very widely applicable. Next up is anomaly detection. So anomaly detection also is something which most of us encounter on a day-to-day basis. Like for example, we say that, man, like people in California love to complain about the weather, right? Like this year the weather is anomalous. Like it's supposed to be like hot, but it is cold. So anomaly detection is something like it is very easy to understand. Like something which doesn't fit the pattern, doesn't fit the mold, you want to identify that. If you, let's say, have a factory, right, and you have an assembly line, so you want to monitor for temperature anomalies or anomalies basically in, let's say, the vibrations of a machine. So you want to detect failures upfront, right? So why did I just go through all of these use cases? HeatWave AutoML supports all of these use cases, and they are all available to you in the database. If your data is in InnoDB or your data is in object store or your data is in some other place, you can basically just run all of these use cases on your data using the same MySQL database that we all love, we all know, we all have a massive set of tools around. So all of it just works. So I mean, these are just some of the use cases that we have seen. We are working with customers on these. So, and of course, like, yeah, so forecasting, anomaly detection, recommender systems, classification, regression, everything just works out of the box. And using this, we have worked very hard to make it not hard for you to use. So we have just this simple 5 set of APIs, ML train, where basically you specify you point ML train to some basically table in InnoDB or in Lakehouse and tell it, okay, go train a model, go train a classification model on my data. And here is the column containing the values I want to predict. So I have some data, let's say, trying to predict, as the example earlier, I want to predict whether a loan is approved or denied. I have some data where each row is a customer, some data about that customer, let's say checking account balance, their previous history and so on, and then I want to predict basically whether the loan will be approved or denied, and that is one column, right? I just point the API to that column and it will just train a model for you automatically. Internally, we have a lot of different things we do. We select the best model for you, we tune the parameters of the model, we figure out the best subset of columns that are relevant. We do a lot of different like intelligence internally, but the idea is here that with one API, you get the best possible model for your data. The next API is ML explain, where essentially we can automatically generate explanations for your data as well. Explanations basically mean I want to know exactly why a particular loan was denied for a customer. So was it the checking account balance? Was it their gender? Was it there basically something else about their previous history? It can give you all that information, and with just a single API invocation. Scoring, of course, is figuring out how good my model is. Predictions is basically making predictions on their basically new data that comes in. For new customers, I want to predict whether the loan will be approved or denied. So these 5 APIs, all of them work for all the use cases I described earlier. You just need to know these APIs, and these are all actually SQL stored procedures and stored functions. So they work with any MySQL application. So talking about some of the new things we have done in the past, let's say 6 months to a year, we have added support for text columns. Now text is currently something which is very cool, right? It's there everywhere, like we all talk about Gen AI, NLP and so on. So now HeatWave AutoML can support text columns in tables. So if your basically column contains a product description, or your column contains basically some description of an item, or basically something about like a summary of or a paragraph or something, we can actually convert that internally into features and use it. And of course, all these MySQL types are now supported with HeatWave machine learning, AutoML, tiny text, text, medium text and long text. And the code example basically shows how you can basically create a table, first of all containing a text column, then import, you have some CSV sitting somewhere, you want to import that into InnoDB, and you can just call ML train to train a model and predict table to actually do predictions. So I'm going to take a quick pause here, and I want to just see, does anybody have any questions? Because I don't want this to just be me talking through slides about anything, about machine learning or whatever, because yeah. Okay, we are good, then I'll move on. So another thing we have added recently is Lakehouse support. So as I said earlier, we can now train machine learning models on data sitting in the object store. So if you have, let's say you have a CSV sitting in some bucket, let's say in S3 or OCI. You just point ML train to that data using Lakehouse, and then we can just basically ingest it and train a model on the data. You don't actually need to load the table yourself. We will do it for you. We will figure out the schema of the table automatically, and we'll actually do the training as well. So all of this, it uses the exact same APIs that I talked about earlier. It just works. So data can be in InnoDB table, or it can be a CSV, a Parquet file, an Avro file, whatever Lakehouse supports, right? All of that should just works. And of course, there is no additional cost to any of this. You use the exact same HeatWave cluster. So one of the other use cases we have now leveraging basically these capabilities I just talked about, right? We added text support, we added object store support. So let's say you have MySQL logs sitting in the object store. We can actually leverage all of these capabilities to build a use case like a log anomaly detection pipeline. So you have logs sitting in object store. You can take a log parser, like it can be any open source log parser, right? You create log sequences, and essentially these just become a text column for HeatWave AutoML, right? And you can use an anomaly detection model in HeatWave AutoML to essentially do log anomaly detection. And we actually are working on this use case for a customer. It works really well, right? So we automatically figure out what model works best, and it's able to detect anomalies, and it's actually very accurate. So this is, for example, one potential use case where you have a log anomaly detection pipeline. Okay, now let's talk about generative AI. A lot of talks have covered this so far, but I want to actually give you guys a more detailed overview of what we are doing here, and then how this actually works with our existing AutoML technology. So as we know, generative AI in HeatWave enables new use cases. For example, content generation and summarization, where you can actually generate insights for enterprise documents. You can do summarization, and like this is one of the most common use cases for LLMs and generative AI. The other thing which this enables is us to do RAG. RAG is very, very powerful in the enterprise setting. A lot of us have a lot of data about which is not public, right? Most enterprises have data which is not public, and you want to be able, you want your answers or your whatever responses you are generating from the LLM to be based off that data. It has to be contextualized on that data. So that is what RAG is, retrieval augmented generation, where essentially you take context from your enterprise data, right, which is what the vector store enables, and then you feed that context together with your query to a language model, and the language model then basically generates an answer, contextualizes the answer that it gives you, and then it's based on the query and the whatever data you give it. And the third thing is, which is also very powerful, which I think the demo showed in the morning as well, natural language interaction. So this is a very useful capability because it essentially allows you to talk to your data in whatever language you are comfortable with. For example, I can just ask questions like, what was my revenue last year? And then this thing will actually go, let's say you have annual reports in PDF form in your bucket. It looks at that data, it retrieves all of it, it's able to answer that question. Okay, your company's annual revenue was whatever $1 million or something last year. So that is very powerful. I don't need to write complex SQL queries to do all of that. So let's take a more detailed look into how RAG actually works. So what do we mean by vector store, and what do we mean by this RAG use case? So let's say you have some proprietary documents sitting in some object store bucket. Using Lakehouse, you can actually ingest these documents. These can be PDFs, this can be HTML, this can be docx, this can be PPTs into HeatWave, right, in the form of a table, right? And then automatically you also generate embeddings. Embeddings are basically think of them as numerical representations of text. So with embeddings, you can actually do a similarity search. So let's say I have a bunch of documents talking about HeatWave, let's say, right? And my question is, and then I have a bunch of other documents as well talking about, I don't know, screens, let's say. So when I ask the question, what is MySQL HeatWave, what this allows me to do is I can actually search through all of these documents very quickly via embeddings. Embeddings essentially compress representations of text, right, which allow me to do very quick comparisons using basically matrix multiplication. If we didn't have embeddings, you can also do like a full text search, but full text searches are very slow, and they do not capture semantic information. By that I mean is that but what semantic information means is that it actually captures meaning in the text. For example, the word queen and monarch are actually similar. They have the same embedding. So that's what embeddings allow you to do. Allow you to do basically very quick searches across large volumes of text. So HeatWave vector store automatically generates all these embeddings for your data, right? All of this happens automatically. And then with RAG, what we do is when I ask the query what is MySQL HeatWave, I actually take this query, find the matching paragraphs in my PDFs from the object store, put both of them together and give this to the language model. Then essentially what I tell the language model is answer the question what is MySQL HeatWave with the following context, and the context is basically the paragraph from the PDF. And then the LLM now knows, okay, I have to answer this question based on this information, and it generates the answer. So that is how RAG works. And that's how basically a lot of these chatbots actually also work. And then, so with HeatWave, generative AI and vector store, you just need to call one API to do all of this. This just happens internally. There is one API to load your data and another API to query your data. That's all. You don't need to know the internals of what everything is happening. Now, I want to take another pause here to if anybody has any questions on RAG or any of this stuff, how it works. Some screens, something. Yes.
What is the executed what is the executed margin for like Oracle compared to Snowflake? RAG will RAG be able to do that?
Yes. So
okay.
Again, that depends. Like if today I ask this question to let's say ChatGPT or Llama 3 or whatever, it will not be able to do that because it doesn't know. It has been trained on some older data, right? But with RAG, let's say I have an annual report from Oracle, let's say from last year, and if that is part of the documents I've fed to it, then essentially it will be able to answer those questions. So it contextualizes the response based on proprietary data. So it makes the LLM, that's something it's very, very useful for enterprises, where essentially you want to, and this also I'll show some use cases as well, where you will actually see how powerful all of this is. Any other questions? Yeah, go ahead.
Hi. Is it able to handle multilingual documents?
That is a very good question, and that is something we are actively working on. Multilingual is something, again, yeah, it's very, very important, like, because, yeah. Okay. Let us move on then. So, one of the things that we realized is once we added generative AI and vector store to HeatWave, and we like a lot of the buzz nowadays is around generative AI, right? But what we realized is that we had these existing AutoML capabilities as well in HeatWave, like classification, regression, anomaly detection. Like that's the reason I talked about all of that. You can actually combine the two of them to create really powerful and useful applications. And because HeatWave as a platform supports all of it, and all of it happens within the same database, your data doesn't go anywhere. It sits there, it is secure, and essentially it creates that's why this is a huge differentiator for HeatWave. You can create a new class of very powerful applications. And let me give you examples to tell you what I mean, like this. So this is the thing I was talking about, right? One of the first use cases is like an assistant, right? So you have some PDFs, let's say, like the example is showing DoD contracts, right? So we just fed downloaded like 5-6 PDFs from the DoD, and like we just fed them those PDFs to a vector store, and we are able to ask questions like directly, like which firm was awarded a contract for Dell laptops, And from all the PDFs, able to quickly tell us like, okay, MCP Computer Products was awarded that contract. Then what about some contracts for the rolling airframe missile? It was able to answer it very correctly. So here you can see like how powerful RAG is. This is like a classic use case of RAG, an assistant for proprietary data. So this, think of it like enterprise search, but like dialed up to 1000. So this is where the integration of AutoML and Gen AI or generative AI really begins to shine. For example, one of the customers we are working for, they have a food delivery business, right? So they have a lot of restaurant menus on their website. So we realized that we actually have support for recommender systems. So you can actually use recommender systems to figure out which restaurants a customer will be interested in based on their past history. You're recommending, let's say, top 3 restaurants, right? And then based on a customer's profile, I know that they like, let's say, they're vegetarian. So what I can do is that I can pull the menus which are PDFs for those restaurants, right? And then because the menus have already been ingested into the vector store, I can ask a query. And using the recommender system, I know that I want to limit my search to just these 3 restaurants. It's actually able to answer questions like, for example, like the customer asks, okay, like what should I eat today, right? So based on the profile, I found out these 3 restaurants would be interesting to the customer, right? I then basically I took the text from the menus, fed it to internally to the LLM, right? And it's able to generate answers like for these 3 restaurants from these menu items, tofu curry, tofu biryani, and peas curry would be interesting to you. So now you can see how you can leverage classical AutoML models or machine learning models and generative AI. Yeah, sure, go ahead. Yes. That is a very good question, and yeah, this was actually asked to me earlier today by somebody else as well. So, and that is the power of doing this within a database, because I keep using the word ingest, right? You can take this PDF, ingest it into the database, right? So what we do by ingest is that we take the PDF, we parse it, split it into chunks, create embeddings, and put those in like a normal table, normal MySQL table. Not InnoDB, but like a HeatWave table. But so it has all the properties of that table. So you control what table it goes into, you control what permissions that table has. So you essentially, you can use the same OLTP, OLAP SQL queries with all of this to control what is searched, what is accessed, everything. So it just behaves as a normal table. Does that answer your question? So not the model, the application. So the application will basically be writing a SQL query, let's say for RAG, right? And the input to RAG will be a vector store table, right? And the table you create, so as I said, there are 2 parts to this. One part is ingest, right? So you use like, there's an API called HeatWave load, which allows you to create a table from a set of PDFs, right? So for example, I say load PDFs matching menu underscore star into vector store underscore menus, this table, like this, let's say some restaurant dot, the schema is restaurant, the table is vector store underscore something, right? So it will take all PDFs matching that, put it into that table, and that table is something that you control the permission. It's created with your user permissions and so on. And then in RAG, when I actually do the query, I can say, okay, limit this query, like which dishes I'm interested in, to this, and this table. Sure. Never expose what? So yeah, that is actually a very good and something that we are working on as well. So right now, because like this is the enterprise use case, right? So this is okay, sure. The question is basically, let's say the documents I'm ingesting contain PII, personally identifiable information. Is there a way to prevent the model from outputting that PII to this? So the way we think about this is that those are your documents, right? And essentially you can control what gets shown. But as to the model automatically filtering PII, that is something that is not there right now, but it is something that we'll work on. Sure. Okay. So anyways, yeah, I hope I am putting ahead, like, yeah, I hope you're getting, like, yeah. So to me, this is like very interesting, where it's not just Gen AI, it is all the machine learning work that has happened in the last 50 years. And Gen AI is just an extension where you can actually make it easier for people to use machine learning, because you have natural language queries and natural language responses to all of this. And you can only build all the systems within HeatWave because everything is in one database, one interface, one set of tools. Now, the last use case, I want to build upon the anomaly detection use case I talked about earlier, right? Let's say you have logs, right? You want to do log anomaly detection. So I want to figure, so with Gen AI now, you can take the output of the anomaly detection model. Let's say the system detected, let's say you're monitoring MySQL logs. System detected there's an anomaly, right? So what you can do is, at the time when the anomaly happened, you take the last 10, 20, 30 logs. You feed them to a Gen AI model, ask it to summarize and give you the root cause of the anomaly. And we actually did that. Do I have that slide? Yeah. And here we have it. It actually pinpointed from the logs what the actual root cause. So this is very, very powerful. You're using an anomaly detection model, your PCAs, your LOS, whatever that we have had for so long. And now you are basically feeding that to a Gen AI model to help the operator root cause the anomaly. So, yeah. Okay. Any other questions? Awesome. Okay. To summarize, basically, as I said, one platform can, all your data sits in one place. You can do machine learning, you can do generative AI. I mean, of course, you can ask, with generative AI, you can ask it to do a poem, but that's not what you guys are here for, right? We want to basically create smart applications which actually add value for our customers, and that becomes possible with HeatWave AutoML plus HeatWave generative AI, and all of this within one platform. Okay, I think that's it.